Hello, welcome back, ladies and gentlemen. This is Joe, and in this video, I will just be following the first steps guide to create a SanDisk card image, otherwise known as an SD card. And the SanDisk card images are used to run Linux operating systems on, or Android for that matter, on socket on a chip devices. There's two things that I should mention is that usually you don't have to follow the first steps guide because other people have already followed the first steps guide and have assembled usable pre-built SD card images targeted for certain Linux distributions, and all you would have to do is download one of these images, write it to your SD card, and then you can take the SD card and plug it into your embedded device and you're good to go. Second thing I should mention is that for the Cubby board 2, they're just starting to work on creating images for it, and there's still work being done. There's a few preliminary images out there that you can use, but just for grins, I'll try creating one myself and see what the result is. Hopefully it will boot up, but you don't know unless you find out. So in this video, I'll just go over part of the steps. I won't do the whole entire thing. I'll just go over getting the tool chain and building uboot and script.bin. The toolchain allows us to compile source code from one architecture to another. In my situation, I'm building on an Intel platform, but targeting it for the ARM platform, which most of these socket on chip devices or embedded devices run on. So I would need to get a working tool chain. One of those is a Linero tool chain. They have another tool chain for Debian, and I'm sure that they have more tool chains than just those two. But the first steps guide, they tell you to go out to this particular website to get a Linero tool chain. And there's a whole list of them here. I actually find it easier to go to releases.linarno.org. And in here they have more stable releases ordered by year and month. And you can go to the latest one, but the problem with doing that is, according to the first steps guide, it says not to use the GCC version 4.8 version. And the only place I can start to get it that's the latest in this list is that still uses 4.7 is from April of 2013. So if I go into that folder, click on Components, Toolchain, Binaries, I can download the one which is, and I also should mention that these are 32-bit, so you'll need to run these on a 32-bit Linux operating system. Otherwise, you'll need to get the source code, which is this crosstool bzip2 file, and you can go and build it manually. But for me, I'll just get the 32-bit compiled versions, and I don't have to compile it myself. So I'm after GCC Linarno ARM Linux GNU EABI HF. HF stands for hard floating point, which uses hardware to do all the complicated math stuff. It makes things run faster. And I'll get the one that ends in .xz. I'll click on that and save it out to the downloads folder. While that's going, let's see what else I can do. I can't really do anything else right now. Just wait for this to finish up. Click on Dash Home, type in Terminal. Click on the terminal icon, and while I'm here, I'll right-click on the terminal icon and choose lock to launcher so I don't have to keep going to dash home. Change the directory to downloads. And if I get a listing, there's the file that I just downloaded. I'll do an xz space -d, which is to decompress, and I'll give it the name of the file. Type in tar xf to extract the tar file. Let me get a listing of it, tar xf. Then I'll copy the tar file that it just got decompressed to. Get a listing now, and I have now a decompressed directory, which is in blue. I'll copy the blue directory and paste it. Change the directory to bin, and I have a listing of all the files. That is the tool chain. Type in pwd, and I'll go ahead and copy the path that it printed out, which is home copy downloads and all that stuff. I'll go ahead and copy that and type in pico tilde / dot bash _ profile. For whatever reason, this never sticks. Type in export path equals, and put in quotation marks $path, close quotation marks, colon, and then paste the path of the tool chain in there. Press Control O, enter to save, Control X to exit. And I'll change the directory back to my home directory and type in source tilde / dot bash profile. Now it's in our path. Following along with the guide, we'll need to obtain a root file system, and again it points again at Linarno. They specialize in Ubuntu. There are separate ways of, it's actually called bootstrapping a Debian file system, which follows a different process. But just to keep in line with the guide here, and what I actually find easier is to go to the releases, and let me go back to the main directory here. So since I got the tool chain from April of 2013, I'll go back into April 2013 folder, go to the Ubuntu folder, and of course my phone rings while I'm making a video. Thank goodness for voicemail. Just wait for this moment to pass. Choose Quantale Images. That's the release of Ubuntu. Someone really wants to get a hold of me. The image that I'm interested in is the ALIP, which stands for Linux Internet Platform. It's a minimal distribution of Ubuntu with a kind of stripped down window manager called LXDE. Click on the ALIP folder, and go ahead and click on tar, the Linarno Quantale ALIP tar.gc file, and save it out to your downloads folder. Now there's an easy option, which I will not do just because I'm dealing with the cubbyboard 2, and currently right now the repositories that I'm using aren't from Linux-SunXI. It's from it's from another developer that's currently doing work with trying to get it to work with the cubbyboard 2. But the easy way to do it is that the SunXI-BSP, BSP stands for Board Support Package. What it will do is it has a handful of scripts that will go ahead and take the root file system that I'm saving out to my downloads folder right now. Is what you'll do is you'll configure it to use the cubby board or cubby board 2, and it will automatically put everything together and write it to your SanDisk card. Won't be doing that just because I have to go out to different repositories, and we'll be doing the flexible, more lengthy option. I will need to run this sudo command. So I will copy, and in the terminal window, paste it, and in addition to libusb 1.0 dev uboot make image and package config, include git. Press enter. And press enter again. Now we'll actually go out and, in usual cases, you'll go out to Linux-sun-xi to clone particular repositories. Here you have your board configuration files, which are the .fex files, which ultimately create something called a script.bin file. You have the Linux-sun-xi repository, which holds the Linux kernel source code, a uboot repository, which is the universal bootloader, and a handful of tools that allow you to do such things as converting the board configuration file from a text format to a binary format. And I'm sure it does even more stuff than that. And in usual circumstances, you'll go out to here, but since things right now are in a state of flux, I will be using a different set of repositories. And if just to future-proof this video, if I add an annotation somewhere in this video to say, just go ahead and use these repositories, just use them. Don't do what I'm about to do. So first, go ahead and clone the uboot repository. You would usually get it from Linux sun-xi, uboot sun-xi. So I would go out to here and copy this URL. But since things aren't really ready yet, I will head out over to Hans's repository. And if I click on the repository's link, what's it doing? Oh, it's opening up the archive. I thought I told it to save. I will actually go out and clone his repository. And you'll see that there's an A20 branch that I'm interested in. So I'll copy this URL for uboot sun-xi for him and type in git clone and paste the URL and press enter. Specifically for this repository, the one that I just cloned, which you wouldn't do if you're using the normal Linux-sun-xi repositories, change the directory to uboot-sun-xi and type in git checkout A20. Now let us build uboot. Inside this repository, there's a boards.cfg file, which holds configuration options for all sorts of socket-on-a-chip devices made by this particular manufacturer. And if you do a search for cubby board, you'll see the cubby boards listed in here. You'll see a cubby board, which is for the 1 gig model, one for FEL, maybe, I'm not sure what that one does, but that's the half gig model, which is the first model that came out, and there's a cubby board too. So what I'll do is I'll go ahead and copy the cubbyboard 2 option, type make, and then paste the board that we want to build the universal bootloader for, space, and from the guide, copy in the cross compile option and paste that on the command line and press enter. Now for the script.bin, I will now need to clone 2 other repositories. So I'll change the directory back to my home directory, and I'll need to get the SunXI tools, which is okay to do for both approaches that I'm doing this for, going the regular one or the kind of the cubbyboard 2 work in progress method. And I'll go ahead and clone the tools repository. Also, you'll need to clone the SunXI boards repository, which holds the configuration options for the particular board. And usually you'll head out to Linux-SunXI, click on SunXI boards, copy this URL, and you can paste in the command line and clone it that way. Now, just for what I'm doing for this work in progress stuff, which may or may not work, I'll head on out to Hans's repository. And clone his version of SunXI boards. So I'll copy this URL, type in git clone, and then paste his URL into the command line and press enter. Returning to the first steps guide and the script.bin section, descend into SunXI tools by changing the directory. So I'll do a change directory on sunxi-tools, type in make fex to bin, and we're good. Go back up one directory, change the directory to sunxi-boards. Change the directory to sysconfig. And in here, change the directory to A20. That's if you're using the cubbyboard 2. If you're using the cubbyboard 1, you'll want to change the directory to A10. Edit the cubbyboard 2 FEX file, or if you're using the cubbyboard 1, you'll edit the cubbyboard 1 FEX file. And according to the guide, go all the way down to the bottom of the file, and these are just configuration entries about certain specifics of the board. And add in, I'll just copy and paste the example because I don't know what the MAC address is for my cubbyboard. I'm sure that's not correct, but I'll just do it anyway. Control-O, enter to save, Control-X to exit. Now I can create script.bin by typing in ///sunxi-tools/fex to bin space cubbyboard 2.fex space script.bin. It's created a script.bin file, and if I take a look at the contents, it's all very unintelligible. I can't read it, but the embedded device can. Now for the kernel, this will take some time to download, but I'll go ahead and get it started and end the video here, and I'll pick it up at a later point. But what you would usually do is go out to Linux-SunXi and clone the Linux-SunXi repository, which holds the source code for the Linux kernel. since I'm kind of doing this work in progress thing of using other developers' code to try to get this thing up and running, I'll switch back over to Hans's repository and clone linux-sunxi. So if I click on here, and if you take a look at the available branches, the one that I will eventually check out would be the sunxi-34-A20-WIP, which stands for work in progress. Copy the repository URL depending if the dust has settled a couple of months from now, and if you're watching the video a couple of months from now, you'll obviously copy it from this location, but I'm copying it from this one instead. Change back to the home directory and type in git clone and paste that URL. And I'll go ahead and let it clone, and we'll pick up this video later. Thanks for watching.